We present AttribIt, an approach for visual content creation that integrates relative semantic attributes into the modeling process to capture design intent in linguistic terms. Using AttribIt, a novice user can quickly realize high-level design goals, such as create a cute toy for a small child. The user creates an initial set of representative parts using the buttons on the right. The initial parts are chosen according to a statistical model of shape and are automatically positioned and glued. When a part is selected, sliders appear at the bottom of the screen. Each slider represents a ranking of parts associated with a semantic attribute. To rank parts, our method learns mappings from geometric features of parts to high-level attribute strengths. The mappings are trained on pairwise comparisons of shaped parts from Amazon Mechanical Turk. The user manipulates a slider to interactively view replacement parts with higher or lower strengths of the attribute. Here the user explores more scary heads. To make a cute toy, we probably want a less scary head. Here we explore heads with decreasing scariness until we find one we like. The semantic controls make it easy to find parts that satisfy the high-level design goal. Along with the conventional sliders at the bottom, we also present several sliders directly on the part, arranged in a wheel. Plus and minus represent increasing and decreasing strengths of an attribute, respectively. A cute toy shouldn't look dangerous, hence we search for the least dangerous-looking torso. Next, we look for a pair of stubby front legs. We could use the same attribute to find a suitable pair of back legs, but for variety we'll use the related attribute less agile instead. Finally, we choose a short tail that suits the animal, and add a pair of wings which we then replace with a more graceful pair. Manual controls allow us to change the size and placement of the wings if we don't like the automatic results. Now we show an example of an open-ended modeling task in the domain of airplanes. The goal is to create an airplane for a computer game that would perform well in aerial combat. We start with a basic configuration of fuselage, wings, tail, and tailplane. We start by choosing a sleeker fuselage for greater speed. Parts are automatically repositioned to match every replacement. Next, we use the wheel widget to choose a more military pair of wings. Now we show an example of modifying the strength of an attribute for two parts simultaneously. The tail and the tailplane are both made more aerodynamic. To increase the chances of our airplane winning an aerial battle, we equip it with several weapons. We also add side landing gear. The automatic suggestion is a little small, so we make it bigger, not by rescaling, which might make it look implausible, but by using the big attribute to select a bigger set of wheels. Finally, we add front landing wheels. The wingtip weapons don't look threatening enough. We'll make them a little more dangerous. We now show exploratory modeling with high-level attributes in the domain of ships. We start our exploration by selecting a less old-fashioned hull. We then add a cabin, antenna, and weapons. We decide the front weapon needs to be a bit larger and explore the selection of larger weapons. The selected gun looks somewhat out of place on this ship, so we look for a more military ship by selecting the entire assembly and increasing the strength of the military attribute. Real-time inference in a probabilistic model of shape extends the ranking to parts that do not possess the military attribute. The final shape is the most military ship comprising parts from these categories. We now add parts from additional categories to the ship. Inference in the probabilistic model is used to select parts that maintain the overall plausibility of the shape. Finally, we remove the rear weapon and replace it with an aircraft.